Hello guys, this is John Dampil from the Polytechnic University of the Philippines, currently taking the program Master of Science in Computer Engineering, and I'm here to present to you my scientific paper review number 2 titled Naive-Bayes Approach to Predict the Winner of an ODI Cricket Game. So the author for this is I. Wickramasinghe from the Prairie View NAM University under the Department of Mathematics from Texas, USA. So let us first mention in the title the naive-Bayes approach. So what's naive-Bayes in the first place? So naive-Bayes algorithm is a probabilistic machine learning algorithm based on the Bayes theorem used in a wide variety of classification of tasks. In this article, we will understand the naive-Bayes algorithm and all essential concepts so that there's no room for doubt and misunderstanding. So technically, it is a classification technique based on the Bayes theorem with an assumption of independence among predictors. In simple terms, a naive-Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature. For example, a fruit may be considered to be an apple if it's red, round, and about 3 inches in diameter, even if these features depend on each other or upon the existence of the other features. All of these properties independently contribute to the probability that this fruit is an apple, and that is why it is known as naive. So basically, in naive-Bayes systems, we have multiple features or factors to consider, but none of them, or what I mean, these factors independently contribute based on the probability of the scenario. So each of them contribute on how will the decision will be made, or how will this decision be considered for a particular circumstance. So a naive-Bayes algorithm is a way of calculating posterior probability. P C pipe X from PC, PX, and PX pipe C, where PC pipe X is the posterior probability of class you target given predictor X attributes, and PC is the priority probability of class. PX pipe C is the likelihood is the probability of predictor given class, and PX is the probability of the predictor. So this is the formula. So example of naive-Bayes algorithm is, for example, we have multiple inputs. Let's say we have 14 um, for weather and for the play, where play is suggesting the possibilities of playing, while the weather discuss the possibility of the weather condition and if they are willing to play or not. So first is we convert the data into the frequency table. So we tally the no and yes and along the weather, and of course the weather. Then next we will make the likelihood table by finding the probabilities. So we first divide them into the total number of counts. For example, for overcast, we have 4 yes, but we have 15 entries. So 4 divided by 14, we get a probability of 29, and so on for the other example. While below, for the probability of no and yes, we have 5 inputs here, which is 3 for rainy and 2 for sunny, total of 5, and 4 for overcast, 2 yeses for rainy, and 3 yeses for sunny, so a total of 9. So we have total 9 of inputs. So the probability of saying no will be 5 divided by 14 over the total number. And for the yes will be the 9 over the total number. So we get also the probability of the response. Now we use the naive equation. So the problem is, will players will play if the weather is sunny. So how can we say yes and how can we say no? Or what is the probability of the players playing when the weather is sunny? So we apply the formula, which is P sunny by PS multiplied by PS uh, slash P sunny. So how are the P sunny by PS? So that will be 3 over 9. Why 3 over 9? Because we have 3 yeses for sunny over the total number of counts, which is 9. So 3 divided by 9 is 0.33. And then the P sunny, which is 5 over 14, which is here. We have 5 responses, so 2 no's and 3 yes. So 5 divided by 14.36. And for the PS, our probability yes, that will be 9 over 14 because we have 9 responses for yes over the total number, which is 14. And we multiply all of them together and we will get the answer of 0.6. So that is, which is basically a higher probability. So which means there's a high probability that players will play if the weather is sunny. Okay. Now back to the study for the paper review. So the Basically, the review applies the Naive-based algorithm to predict the winner of an ODI cricket game. The study emphasizes and aims to ensure that we understand and we can apply Naive-based system to process probabilities and generate predictions and safe assumptions. In statistics, Naive-Bayes classifiers are a family of simple probabilistic classifiers based on applying Bayes' theorem with strong independence assumption based between the features, and they are among the simplest Bayesian network models. But coupled with kernel density estimation, they can give higher accuracy level. Now, for the methodology, basically the data source, they have used the ODI records from September 30th, 2018 to January 1, 2020. So basically, these are previously recorded games. These data serves as the main data to study and apply the algorithm. So with additional information here, we have including ICC ranked teams, Afghanistan, Australia, etc. So the AI can be characterized by a collection of performance indicators. So they have four categories here, which is batting, bowling, team, and the others, along with the mean values and the variable for each of the categories. So moving forward for the data methodology, Naive-Bayes classifier, they have used the NB classifier, which is a popular supervised learning technique in machine learning, due to its simplicity, speed, and accuracy. So another advantage for NB classifier is that it can be used even we have a small amount of data sets. For model constructions, basically this represents the mathematical formula in applying the Naive-Bayes algorithm. While the classification process, it is the process of data collection, and the data were pre-processed and were converted into format so that analysis can be performed. This is similar to the step we did here. So basically you have your raw input or raw data, and then you create a table, a frequency table and a likelihood table, and from there you get a probability of each so that you can apply our formula here, which is the multiplication of all the variables. From there, the last one will be quantifying the performance, which will become the output or plotting of the confusion matrix, like this. So loose, negative, and loose negative, that is Tn. Fn is loose negative when positive. Tp is when positive, loose negative is, and when positive is Fp. Now for the findings, Zimbabwe has not recorded any wins, while England team shows a maximum difference between the number of wins and losses. This basically means that Zimbabwe, here we can see they all have their games lost, while England have the highest wins at the same time the lowest number of losses. That's what meant with they shows the maximum difference between the numbers of wins and the number of losses. And also Afghanistan, Bangladesh, and Sri Lanka teams have lost more games than they have won. So if we refer to Bangladesh here, they have more losses than wins. Same with Sri Lanka, Pakistan, and Zimbabwe. And the West Indies, they have more games lost. Additional to the study findings, we were able to compute the median score of about 300. That means median score is where most of the values meets or meet like an average. So it's an average win for 300 around on this section. So all the greens almost intersect at this point. And for the red, it's about 230, where most of the reds intersect, which defines the lost value for the games. England team has always maintained a higher median winning about 350, which is this one, and score winning of about 275, which is about here. Pakistan became the likeliest team for not winning the game, having maintained a median score of 275. For the study gaps and opportunities in this paper, we have applied the NB algorithm for predicting the ODI cricket game based on the performance of the first inning of the game with an aim to achieving higher education and accuracy. We investigated the best combination of training and testing sample size to train the test, the Naive-Bayes model. Despite the fact that NB displays significant variance in winner prediction, it is always recommended to have a large data set. So that's the first opportunity, is that we can use larger data set compared to the ones used here, so we can get more accurate result. In this study, we considered only 15 variables to represent and cover the aspects of the game cricket. It would have been better to consider some additional attributes such as handness of the batman, and bowler. Finally, it is always recommended to use an appropriate feature selection algorithm not only for the reduction of the dimension of the data, but also to minimize the impact from the violation of independent assumption. So for the study gaps and opportunities, this basically means that most part of it suggests that we can always use more data sets to support more data and more variables, and at the same time get more accurate output and decision using the naive-Bayes algorithm. So basically, that's all for my presentation. Thank you very much for listening, and I hope you always have a nice day and take care. Thank you very much.